Unit 2.9, Graphs, Roots, the Axis, and the Discriminant. Today we're going to connect the number of roots of a quadratic equation, the number of x-intercepts of the graph of a parabola, and the value of the discriminant. We also are going to connect the axis of symmetry to the x-intercepts of the graph of a parabola. Please remember the quadratic formula is derived from the standard form of a quadratic. In red, you can see that the discriminant is what's under the radical, b squared minus 4ac. You also can notice in the blue the formula to find the axis of symmetry, negative b over 2a, as well. When we look at b squared minus 4ac, we call this the discriminant. If the discriminant is greater than 0, we are going to have two real solutions, meaning it is going to connect or cross our x-axis in two places. If the discriminant b squared minus 4ac is equal to 0, we are only going to have one real solution, meaning that our vertex is on our x-axis. If b squared minus 4ac is less than 0, so it is a negative number, we are going to have two imaginary solutions, which means it is not going to cross our x-axis, so we will have no x-intercepts. If we're looking at a perfect square, we will always have two real rational roots. If we are looking at not a perfect square, we will have two real or irrational roots. Example number 1 says examine the quadratic x squared plus 1 equals 0. So the first thing we can do is we can list our a as 1. There is no linear term or b, so we put 0, and our constant is 1 as well. So when we compute or plug these values into b squared, 0 squared minus 4 times 1 times 1, we get negative 4. So we would say the discriminant is a negative. So x squared plus 1 equals 0, because it is a negative, would have two complex roots. Complex roots means imaginary. You can then notice when we take a look at our graph that our graph is not ever going to cross our x-axis, so we have 0 x-intercepts. Example number 2, if we examine x squared plus 4x plus 4, our a is 1, our b is positive 4, and our c is also 4. When we plug those into our discriminant, 4 squared minus 4 times 1 times 4, we get 16 minus 16, which equals 0. So our discriminant is 0, which means we will have one real root. When you look at your graph, you can see that that real root is on the x-axis, which means we have one x-intercept. When we look at example 3 and we examine x squared plus 6x plus 5, we notice that our a is 1, our b is 6, our c is 5. When we square b and subtract 4 times a times c, we get 36 minus 20, which equals 16. Our discriminant, we would say, is positive. If we have a positive discriminant, we have two real roots, which means it's going to cross our x-axis in two places and have two x-intercepts. Example number 4 says find one possible pair of integer values for a and c so that the equation ax squared minus 4x plus c equals 0 has one real solution. Then write the equation. So to determine something that has one real solution, we would want our discriminant to equal 0. So if we write our formula out for the discriminant and set it equal to 0, we can then plug in the information we have. We know that b is negative 4, so we have negative 4 squared minus 4 times a times c, which we don't know, equals 0. So 4 squared is 16. When we use our inverse operations, we get negative 4ac is equal to negative 16. Divide by negative 4. We get a times c is equal to 4. So if we wrote an equation, we could have a could equal 1, c could equal 4 to multiply to get 4. A could equal 4, C could equal 1, A could equal 2, or C could equal 2, are combinations of numbers that could get us a positive 4. So if we plug any of those into our equation, we could have 2x squared, if I choose these bottom ones, minus 4x plus 2. If I choose these, we could have 4x squared minus 4x plus 1, or we could have had x squared minus 4x plus 4. If we ignore the square root part of the quadratic formula, we have the formula x equals negative b over 2a. That is the formula that tells us where the axis of symmetry is located. We can also find this by averaging the two roots. That is only if we know what our x-intercepts are. You can see that on this graph we have a root at negative 5, a root at negative 1. If we use our negative b over 2a from the original quadratic formula, we get our axis of symmetry is negative 3. If we average our roots, negative 1 and 5, so we add those two together, divide by 2, we also get negative 3. Example number 4 says 4y equals 3x squared plus 6x plus 5. Find the axis of symmetry. So because we do not know the roots, we could use x equals negative b over 2a is one of our options. I know my b is 6, so if I do negative 6, put it over 2 times 3, I get negative 6 over 6, which equals negative 1. So my axis of symmetry is at x equals negative 1. In example 5, if we have negative 4, 0, and 10, 0, these are the x-intercepts of the parabola. So we can find the axis of symmetry by averaging those. Negative 4 plus 10 divided by 2. So we get 6 over 2. So our axis of symmetry would be the line x equals 3. Example number 6 says a quadratic equation has the roots 3 plus I and 3 minus I. Find the axis of symmetry. Remember, roots are also x-intercepts, solutions, zeros. So if we average those, we would take 3 plus I plus 3 minus I divided by 2. 3 plus 3 gives us 6. I plus negative I, they disappear. And 2 stays in the denominator. We would get our axis of symmetry, the line x equals